In this tutorial, I'm going to show you the easiest way to make GraphQL APIs with TypeScript. So we're going to be using TypeGraphQL and we're going to be using Typegoose for our Mongoose models. So who is this tutorial for? This tutorial is for those that are familiar with Node.js, those wanting to learn GraphQL or TypeGraphQL, and those wanting to learn TypeScript. If you don't know GraphQL, should you watch this video? Some of the syntax in this video is going to be a little bit confusing. If you have a basic understanding of GraphQL, following along with this tutorial won't be too difficult. So why are we going to be using TypeGraphQL? Well, TypeGraphQL is going to reduce the boilerplate. Without it, you have to update the schema, data models, resolvers, and type definitions. With TypeGraphQL, you only need to update resolvers and data models. So what is a decorator? A decorator is a function that uses this @ symbol and then the expression. And then the expression is going to evaluate to a function that will be called at runtime with information about the decorated declaration. If you want to read more about decorators, you can go to the TypeScript documentation. To help make the syntax a little bit less confusing, I'm going to give you a demo of what we're going to be creating, and then I'm going to give you a walkthrough of the code base before we create it. So when we create it, it's not going to be the first time that you see the syntax. So this is the API that we're going to be creating. So we can create this user here, given this input down here. And if you want to create all these mutations and queries yourself, in the README, you can copy the query and the input. So we've created this user here. And next we can log in, given their email and password. And you can see we get back an access token. And if we have a look at the settings in here, you can see that we have request.credentials set to include. By default, this is going to be set to omit, but if you have this set to omit, it's not going to send along the cookie that we get when we log in, and you're not going to be able to access authorized routes. So if you hit the me query, you can see here we get back the currently logged in user. Next, we can create a product. And then we can get a list of products. So you can see here we only have one product. And if we copy this product ID and then make a query for a single product given the product ID, we get back that single product. So the magic is going to start in the index.ts file. And you can see here that we're going to bootstrap a new Apollo server. We're going to be using Apollo with Express, and this is so we can use Express middleware. So we're going to be using Apollo version 3. If we have a look in the package.json here, you can see we're using Apollo version 3.5. And so there's going to be a few new things. For example, if you want to expose the playground, like I just showed before, you need to use this Apollo server plugin, landing page, GraphQL playground import. And so you can see down here that we're using plugins, and if the environment is production, we're just going to use the production default. And if we're not running the application in production, then we're going to show the playground. And finally, we're going to serve the application. So if we come into schemas, you can see a bunch of really weird syntax in here. So you can see we're exporting a class here called user, and we have this @pre, and @pre is going to come from Typegoose. And this is going to allow us to create a pre-save hook. If you're familiar with Mongoose, this is going to be the same as a Mongoose pre-save hook, but we're just going to be doing this inside of a decorator. Next, we're going to add an index for email, and this is so we can query users efficiently by the email address. And index is also going to be coming from Typegoose. Next, we're going to add a query method of find by email. And so this is a method that we can use on our model to find a user via the email address. Next, we're going to create an object type. An object type comes from TypeGraphQL. So you can see here how Typegoose and TypeGraphQL play really nicely together. Then we have our user and we have field. And field comes from TypeGraphQL. And we have a field here for the ID. And down here, you'll notice we have a field and a prop, and prop comes from Typegoose. So this is us defining our property on our Mongoose type. And then we have email has field and prop again. And then we have password is not a field, but it has a prop. And this is because we don't want users to be able to query for the password when you're querying for a single user. Next, we're going to define some input. So we're going to have a create user input. And you'll notice here we have input type. And input type is going to come from TypeGraphQL. And then we have another field down here. And again, this is just a TypeGraphQL field. And then we have this other decorator here called isEmail. And isEmail is going to come from class validator. And class validator has a bunch of really handy methods to make sure we validate our input when we create objects. So we're going to make sure that we're creating users that have valid email addresses. And for our password, we're going to make sure it has a minimum length of 6 and it has a maximum length of 50. And then finally for our login input, we're going to have a field for email and a field for password. Our product schema is going to look very similar. We're going to have an index for the product ID. This is going to be an object type. And then we're going to have some fields and some props. And then down here, we're going to have our create product input and our get product input. So if we go have a look at our resolvers, you can see in our user resolver, we have a mutation decorator, and our mutation is going to return our user object. And so our user object can be used here because we have this object type here. So this means that our user is going to be our TypeScript interface. It's going to be our object inside of our GraphQL schema, and it's also going to be our Mongoose model. So we have some args here to create a user, and this is going to be our create user input. And then we're going to call the user service to create a user. And we're going to return the result of this create user method. We have a mutation for logging in and a query to get the currently logged in user. Our product resolver is going to look very similar. We have this authorized decorator here, and authorized is going to come from TypeGraphQL. So we can write our authorized function and we can have this auth checker here on our build schema function. So if we have a look at auth checker, you can see we're just looking in context for our user. And we're going to say if the user exists in context, then they're going to be authorized. You can add whatever logic you like in here. So you can add roles if you like, and you can add permissions, all sorts of stuff. So how does our user get onto context? Well, if we go back to index, you can see here when we start Apollo server, we're going to build context here with this function. In context, we're going to look inside of our cookies for an access token, and then we're going to verify the JWT, and then we're going to add the user to context.user. Then we're going to return context, and then this context can be used anywhere inside of our application by using this CTX decorator here. Finally, we have our services, and these are just going to be plain and simple functions that are going to interact with our model. The last thing to show is config. So we're going to have some default config here, and this is using the config module. So if you have a look in our JWT utils, you can see we're importing config, and then we're going to get our private and public key, for example, from config. So you'll also notice we have this custom environment variables, and this is so we can set our private key and public key inside of a .env file. So we have this .env file here with our public and private key, and these are base64 encoded, and we're going to decode those in JWT utils. And then we can use our .env and load these into memory when we start the server, because we use .env here, and then we call .env.config. So let's get started building this GraphQL API. So I'm here in a new VS Code window, and I'm going to make a new directory, and I'll call this TypeGraphQL tutorial. I'm cd into TypeGraphQL tutorial, and I'm going to initialize the application with yarn init. I'm going to press enter for all these questions. And then I'm going to initialize TypeScript with npx TypeScript and the -- init flag. If you want to find all these commands, including the yarn install commands, you can find those inside of the finished repository in a file called notes.md. So I've opened my project in a new VS Code window. You can see here now we have a package.json and we have a tsconfig file. And we're going to need to modify this tsconfig file. Before we do that, let's install some dependencies. So you can find this yarn install command in the notes.md file of the finished repository, and you can find a link to the finished repository in the description below. Let's install these dependencies. And next we need to install some development dependencies. So let's go inside of our tsconfig file, and we need to change our target to ES 2018. And so 2018 is the minimum target that we need. Our module should be common.js, so this is going to be correct. Then we need to come to lib, and inside of lib we need to add an array. So we need to add ES 2018 and ESNext.async iterable. Next, we need to set experimental decorators to true, so you can just uncomment this line. And you need to then set experimental decorator metadata to true, so again, just uncomment this line. And then we need to set strict property initialization to false. So we can uncomment this line and set this to false. Let's make a new folder, and I'm going to call this folder source. And then inside of source, I'm going to make an index.ts. You can obviously call this whatever you like. So I'm just going to add a console.log hello world. So let's come into our package.json, and I'm going to add scripts, and I'm going to add a dev script. And my dev script is going to be ts node dev --respawn --transpile only. And then we're going to start source /index.ts. So let's try this, yarn dev. And you can see here we get our server starting and we get hello world. So let's create a config folder. So I'm going to create a folder in the root directory called config. And then inside of config, I'm going to create another file. And this is just going to be our default config. So you need to create a file in here for each environment that you're going to be developing for. So we can create another file here called production.ts. And this is obviously going to run only in production. And it's going to merge in the config from default into production. So we can create another file as well, and we can call this development.ts. And this is environment variables that are going to run in development. And then you can also create another one called test.ts. And these are variables that you're going to be using inside of test. So when you run Jest, for example, your node environment is going to be set to test by default. So let's come into default. I'm going to say export default, and I'm going to say db URI, and then I'm going to put a Mongoose database connection string. You can call this database whatever you like. Let's come into development. We can remove this. And so our default is just going to get merged into development, and then we can do the same for production and for test. So let's create a new file in our root directory called .env. And this is going to contain our environment variables. So I'm going to create an environment variable called private key, and I'm going to create another variable called public key. So to get our public and private key, I'm just going to come to Google and I say generate public and private keys online. So I'm going to come to this first link, and you can see here we get a private key and a public key. Generate into some new keys here, and we want these in base64 format. So let's come over and say base 64 online, and we can get this encoder here. And make sure you click encode, this second link here. Paste in the key, and then I'm going to click encode. Then you can copy the value from here. And this is going to be our private key. And the reason we're going to base 64 encode these keys is because otherwise they needed to be formatted perfectly inside of your end file, and that can be quite annoying. Let's do the same here for the public key. And this is our environment variable setup. Let's come into index.ts, and I'm going to import .env from .env. And then I'm going to say .env.config. And then I'm also going to import reflect metadata. Next, let's import express from express. And I'm going to create a function here called bootstrap. And then I'm just going to execute the bootstrap function. And bootstrap needs to be an async function. So the first thing we need to do is to build the schema. Then we need to initialize express. Then we need to create the Apollo server. Then we need to call await server.start. Then we need to apply middleware to server. And then we need to call app.listen on our express server. And then we also need to connect to database. Let's go through and start meeting these requirements. So I'm going to say const schema is equal to await build schema, and build schema is going to come from TypeGraphQL. So I'm going to remove this import here, and I'm going to try and get it to automatically import from TypeGraphQL. There we go. We're going to execute build schema. It's going to take an object of options. And so we're going to have resolvers, and we need to create our resolvers. And then we're also going to have our auth checker function. So we need to create these two functions here. So before we do that, let's initialize express. So I'm going to say const app equals express. I'm going to say app.use cookie parser, because otherwise we're definitely going to forget to do this. And then we're going to create our Apollo server. So I'm going to say const server equals new Apollo server. We're going to pass in our schema that we created up here. And we're going to have a function for context. So for right now, we're just going to return context. I'm going to say CTX, and I'm just going to return CTX. And let's also console.log it. Inside of plugins, we're going to use our Apollo Server plugin landing page production default and Apollo Server plugin landing page GraphQL Playground. So this is going to allow us to turn the playground on while we're developing locally and turn it off in production. And this is what's required for Apollo Server 3. So plugins is going to be an array. I'm going to say process.n.node.n equals production. Then we're going to use Apollo Server plugin landing page production default. We're going to execute that function. Otherwise, we're going to use Apollo Server plugin landing page GraphQL Playground. Then we're going to call await server.start. Then we're going to apply some middleware. So I'm going to say server.apply middleware. And then we're going to give it app. Next, let's call app.listen. And we're going to give this a port of 4000. And then we're going to give it a callback that just says console.log. App is listening on HTTP local host 4000. So we're getting a lot of errors here, and this is because we don't have our resolver or auth checker. Let's comment out auth checker and we can create our resolver. So before our server will start again, there's going to be a fair bit of work. So let's create our resolvers. So I'm going to create a new folder in here called resolvers. And then inside of resolvers, I'm going to create a new file, and I'm going to call this file user.resolver.ts. And then inside of resolvers again, I'm going to create an index.ts. And this is so we can export all of our resolvers. So inside of our user resolver, I'm going to create a mock resolver for getting the current user. So I'm going to say export default class user resolver. And then I'm going to add a query on here. So I'm going to say add query, and then this should import from TypeGraphQL. And then I'm going to say me. And so this is the query that's going to show up inside of our GraphQL playground. And I'll show you this in a second. And then for the me query, we're just going to return, and we're going to make a fake user here. So I'm going to say _ID, and this is going to be 123. And we're going to have a name, and the name is going to be Jane Doe. And then the email is going to be Jane Doe. But this query isn't going to work yet because it doesn't know what it is that we should be returning. And what we should be returning is a user object, but we don't have a user object yet. Let's create this. Let's create a new folder called schema. And then inside schema, I'm going to create a new file, and I'm going to call this user.schema.ts. And then I'm going to create my user schema here. I'm going to say export class user. We're going to have a field. And remember, field is for TypeGraphQL. So this is our GraphQL type. And this is going to be of type string. And we're going to have a read only. And we're going to have an _ID. And this is just going to be a string. So this is going to be our GraphQL type. And then this is going to be our TypeScript type. We're going to have another field. Again, this is going to be a string. We're going to have @prop. And so you can see this comes from Typegoose/Typegoose. And this is going to be our MongoDB type. So we're going to say required is true. And if you've worked with Mongoose, then this is going to look very familiar. And this is going to be called name. And name is going to be a string. So let's copy this. I'm going to copy it twice. And I'm going to call this one email. And then the final one is going to be password. And for password, we want to remove the GraphQL type. Let's come back into our resolver. And so we can say that this me query is now going to return a user. So our server's still not going to start because we're not exporting our resolvers. So let's import our user resolver. So import user resolver. And then we're going to export const resolvers. And then this is going to be an array. So we're going to put our user resolver, and later on, we're going to put our product resolver in here as well. And we're going to say as const. Let's come back into our index and we can import our resolvers. I'm going to say import resolvers from resolvers. So you can see here we're still getting some errors, and if we have a look at user resolver, TypeGraphQL doesn't know that this should be a resolver. So we need to add an @resolver decorator to the top here. So we're still getting an error here, and it's because it doesn't know what type user is. So we have our class here called user, but we don't have any decorators. So TypeGraphQL doesn't actually know that this is an object type. Let's add @object type, and this is going to come from TypeGraphQL. So you can see here our app is now listening. Let's go back to our playground, and we'll hit this me query here. And you can see we get back me with the ID of 123, the name of Jane Doe, and the email address of Jane Doe. So let's create a mutation for creating a user. But before we do that, we need to create a user service. So let's come into our source directory, and I'm going to create a new folder. I'm going to call this service, and I'm going to create a new file called user service. So I'm going to say user.service.ts. And I'm going to create a class user service. And I'm going to create a function on here for creating a user. I'm going to say async create user. And we're going to have some input here. And we need to be able to type this input. And now let's just say it's any. And then we need to call our user model to create a user. We don't actually have a user model right now. All we have is a user schema. So let's export our user into a model. So I'm going to say export const user model is equal to get model for class, which comes from Typegoose. And we're going to pass our user schema inside of here. So now let's return user model dot create, and we're just going to pass in our input. Let's export this user service, export default user service. And inside of the resolver, let's add our user service. So I'm going to use a constructor here. So I'm going to say constructor, and then I'm going to say private user service is going to be of type user service. I'm going to say this.user service is equal to new user service. So now we can add a mutation for creating a user. So I'm going to say @mutation, which comes from TypeGraphQL. And this mutation is going to return the user. And then I'm going to say create user. So basically what you're doing is you're saying to GraphQL, I'm creating a mutation here. And then immediately you're going to create the function that handles this mutation. Where usually you'd have to add this to the schema and then to the resolvers and all sorts of messing around. So we're going to return this.userService.createUser. And create user requires some input. So I'm going to say input here. Now to get the arguments and to define the arguments, we're going to use @arg, which comes from TypeGraphQL. I like to call my arguments input, and I'll show you in the playground what this actually means when you use the input string here. Then I'm going to say input, and this is just naming the variable here. And then I'm going to say create user input. So create user input is the TypeScript definition, and it's also going to be the GraphQL definition. So we need to create this create user input. Let's come back to user schema. So I'm going to use an @input type. So you notice that this is going to be different to an object type. You cannot use object types as your input type. GraphQL forbids this. In fact, even if you use just normal GraphQL, you have to create a type for input and a type for your object definitions. So we're going to say export class create user input. Then we're going to have @field. And remember, field comes from TypeGraphQL, so we're defining a GraphQL type here. And this field is going to be a string. And then this is going to be name. And then this is going to be the TypeScript type. So remember, GraphQL type, TypeScript type. Copy this down, and we're going to have an email address here. And let's use @isEmail, and this is going to come from class validator. So you can see here from class validator, there's lots of different validation functions that you can use. We're going to be using isEmail, and this is going to check that it's an email address. Next, let's create our password. And instead of isEmail, we're going to use min length, and our minimum length is going to be 6. And then we can provide a message here. And this message can say password must be at least 6 characters long. Let's do the same for a max length. And we're going to set this to 50. And then we're going to say password must not be longer than 50 characters. So let's import this create user input inside of our user resolver. So this resolver should now work. So we'll go back to our GraphQL playground and let's try create a user. And you can see that this is just hanging here. And the reason for that is because we're not actually connected to a database. So let's come back to our index. And you can see here, we're missing the final part, connect to a database. So inside of our source directory, let's create a folder and we'll call this utils. Inside of utils, I'm going to create a file called mongo.ts. And inside of mongo.ts, I'm going to import Mongoose from Mongoose. I'm going to import config from config. And Mongoose is a default export, so we don't need any curly brackets there. Then I'm going to say export async function connect to Mongo. And I'm going to add a try catch block. And we're going to catch our error. And let's just console.error. And we're going to console error our error. And then we're going to say process.exit. And we're going to exit with a status code of 1, which means something has failed. Next, we're going to say await mongoose.connect. And we're going to connect to config.get. And this is going to be our DB URI. And this comes from our default config here. Then let's just say console.log connected to database. So you obviously need to have a running instance of MongoDB for this to work. Let's come into our index. Let's say connect to Mongo, and we'll execute that function. And we get connected to database. Let's come back to our GraphQL playground and we'll try hit this create user mutation again. And you can see we successfully created a user. So before we move on, let's address quite a large security issue that we've introduced into our application. When we create users, we're storing their password in plain text, which is obviously not acceptable. So to fix this, let's use a pre-save hook on the Mongoose model. Let's come into the schema and we'll come into the user schema. And up here where we have our user class, we're going to use @pre. And pre is going to come from Typegoose. So I'm going to import pre. And then pre is going to take 2 arguments. So the first argument is save, because we want this to run pre-save. And the next one is going to be a callback function. So this is an async callback function. And inside of pre, we have this generic. So we can chuck a user inside of this generic. So we can say user, and this is going to type. And this generic is going to type this for us. So let's say if not this, which is user, dot is modified, and then is modified takes an argument of password, then we can return. So basically what we're doing here is we're going to check that the password is being modified. And if it's not, then we're just going to return out of this function. But if the password is being modified, then we're going to hash it with bcrypt. So I'm going to import bcrypt from bcrypt. And I'm going to say const salt is equal to await bcrypt dot gen salt. And we're going to gen this with 10 rounds. And I'm going to say const hash is equal to await bcrypt dot hash sync this dot password, and then we're going to pass in the salt. So this dot password is the password that the user is trying to set, and then we're going to hash that password. Then we want to swap the password out, so we're going to say this dot password is equal to our new hash, and this is it. This is all it requires to hash our password. So if we have a look at the user object that we created before, and I apologize, Robo3T won't let me zoom, you can see here that the password is in plain text. So let's remove this user. We'll come back to our GraphQL playground, and I'm going to create this user again. And if we have a look at this user now, we have a hashed password. So this is working perfectly. Let's go create our login resolver. So I'm going to copy the create user mutation, and I'm going to call this mutation login. And instead of returning a user, we're just going to return a string. And the string is going to be the token. So our input is going to be login input, and we need to create this login input. And then we're going to call this .userservice.login. And we're going to pass in input. We also want to pass in context because we want to be able to set a cookie. So let's say @ctx, and ctx is context, and that's going to come from TypeGraphQL. We need to execute ctx, and then we can say context, and we need a context type. So we want to be able to create this type ourselves. So let's come into our source directory and create a new folder. I'm going to call this types. And then I'm going to create a new type called context.ts. And I'm going to say interface context. And we're going to have a request object, we're going to have a response object, and we're going to have a user object. So let's type all these. Request and response are going to come from Express. So import from Express and response. So we can add this to request, add this one to response, and our user is going to be our user type. Let's say export default context. And now we can use this context type on our login. So make sure it comes from type/context. And let's create this login input now. So inside of our user schema, say @input type, and we say export class login input. I'm going to say at field, and then this is going to be a string. And to log in, we need an email, which is a string. And we need a password, which is also a string. Let's come back to our user resolver, and we're going to say login input, and we're going to import this input here from our user schema. Now let's create this login function inside of our user service. So I'm going to say async login, and this is going to take our login input. So I'm going to say input login input. And while we're here, we can type our create user input. So I'm going to say create user input, and that's all going to come from the user schema. And we also get context here. And this is going to be our new context type. So there's a few things we want to do here. We want to say get our user by email. We want to validate the password. And we want to sign a JWT, and then we want to set a cookie for the JWT. And finally, we want to return the JWT. So to get a user by the email address, we could create a get user by email service here. And in fact, that's the way that I would probably prefer to do it. But I'm going to show you a little bit of a different way in Typegoose in case you like doing it this way. So come into the user schema, and at the top here, I'm going to create a function called find by email. And find by email is going to take two arguments. It's going to be this, and we're going to type this as return type of user. And then we're also going to add query helpers, and we're going to have to create this query helpers interface. So down below find by email, we're going to say interface query helpers. And query helpers is going to have find by email. And this is going to say as query method type of. And basically what we're doing here is extending the functionality of Mongoose to include this find by email method. And this is going to be type of find by email, which is this function here. And then the second argument here is going to be email, and this is going to be of type user, and then we can pass in their email here. Otherwise, this could just be a string like that. But user email, it's a little bit more specific. Then we're going to say return this dot find one, and we're going to find one by email. And return type should actually be return model type, which should be imported from Typegoose. Okay, so this is looking good. We need to add our find by email to an annotation on our user object. So I'm going to say at query method, and then I'm going to pass in our find by email function. And then finally, to type this properly, when we export our model, we're going to say get model for class. We're going to add a generic here. So the first argument is going to be type of user, and then we're going to add our query helpers as the second argument inside of the generic. So because we're finding users by their email address, we should add an index to the email address. Let's use Typegoose's handy index annotation for that. So I'm going to say at index. And this is going to come from Typegoose. And then this is going to take an object. And then we're going to say we want to index email, and we're going to put a 1 as the property. Let's come back to our user service, and now we can get our user by email. So I'm going to say const user is equal to await user model dot find, dot find by email. Then we say input dot email dot lean, because we don't need to use any of the methods on this user. Let's check to see if the user actually exists. So I'm going to say if not user, I'm going to throw a new Apollo error, invalid email or password. So this error message here should be generic. So if the user doesn't exist or they got the password wrong, it should throw the same error. So we could extract this out into a constant if we wanted to. So we could say const e is equal to invalid email or password. And we can throw a new Apollo error with e. So now let's validate the user's password. So I'm going to say const password is valid is equal to await bcrypt. So we need to import bcrypt from bcrypt dot compare. So we're going to compare the input password against the user dot password. And then we're going to say if not password is valid, then we're just going to throw new Apollo error and we're going to pass in the same error message that we defined above. Now we need to sign a JWT, but we don't have a function to sign JWTs. So let's go off and create that function. So inside of utils, I'm going to create a new file and I'm just going to call this jwt.ts. And you could just sign the JWT inside of the user service, but it's personal preference that I like to create utility functions for signing and verifying my JWTs. And it keeps all that logic nice and neat in its own file. So I'm going to say export function sign JWT. And then I'm going to export another function while we're here for verifying our JWT. So I'm going to create another function while we're here for verifying our JWT. I'm going to say export function verify JWT. So we need to import our public and private keys. So to do that, I'm going to use config. I'm going to say import config from config. And I'm going to say const public key is equal to config.get. So in our config, we have no way of getting our environment variables from our .env file into our config. Let's make a new file. I'm going to call this custom environment variables.ts. Then I'm going to say export default public key. And we're going to have a public key with a key of public key in all capitals. And then we're going to do the same for our private key. So this property here, private key in uppercase, needs to match what you have in your .env file. So you can see here, public key, private key, all our capitals. And then this public key, private key in camel case here is what we're going to use when we use config.get. We're going to say config.get public key. And .get takes a generic. At the moment, it's just unknown. But we know that this is going to be a string. So our keys at the moment are going to be base64 encoded. So we need to decode those keys. So I'm going to say buffer.from. And then the first argument is going to be our base64 encoded string. And the second argument is just going to be base64. So we're telling it what we're actually decoding from. And then we say toString. And then we want ASCII. So let's do this same thing for our private key. And I'm going to say console.log private key. And I'm going to do the same for the public key, just to make sure that these look correct. So to get this file to run inside of our user service, we can import the signJWT function. So I'm going to say const token equals sign JWT. And so we console.log out our keys. And you can see here that these look like perfectly formatted public and private keys. So now let's code up our signJWT function. So we're going to take an object, and this object is just going to be our payload. And we can type that as object. And then we want some options. And our options are going to be optional. And these are going to come from jwt.sign options. And we need to import jwt, or they can be undefined. So inside of this function, I'm going to return jwt.sign, and we're going to pass in our payload as the first argument. Then the second argument is going to be our private key. And then the third argument is going to be our options if they are included when we call this signJWT function. So I'm going to say ... Then we're going to say options and options. So we're only going to add to our options if they are actually defined. If they're undefined, we're just going to leave this empty. And our algorithm is going to be RS256. Now let's do our verify JWT function. So I'm going to try and catch, because when we call jwt.verify, if we cannot verify the function, it's going to throw an error. But we just want to return null. So I'm going to say const decoded is equal to jwt.verify, and we want to pass in our token. So we need to get our token up here, and it's going to be a string. And then we want to pass in our public key. Finally, we want to return decoded. So we can make this function take a generic. So we can say here t, and this is going to be what we expect decoded to be. So we take in t here, and then we're going to say we're going to return t. And then we have an issue here. So we're going to say decoded is as t. And this function obviously returns null if we catch. So we're going to say it returns t or null. Okay, let's come back to our user service, and we can call signJWT, and we can sign our JWT with our user object. Next, we want to set a cookie. So I'm going to say context.res.cookie, and I'm just going to name my cookie access token. And the payload is going to be token, and then we're going to have some cookie options. So our cookie options are going to be max age of this number here, and this is 1 year in milliseconds. HTTP only is going to be true, so we're not going to be accessing this cookie via JavaScript. Domain is going to be localhost. You're going to want to set this domain in your config. Same side is going to be strict, and then secure is going to be false. So instead of false, we can use process.env.node and equals production. So if we're running this in production, then node.env is going to be true. So if we're running this in production, secure is going to be true, which means this cookie can only be accessed via HTTPS. And finally, let's return our token. So now let's go try login. We can come over to login, and we get an unknown type login input. Let's come back to our resolver. And we need to pass context into our result here. We can save this. Let's try it again. And we get a token here, and we should see a cookie get set as well. So now let's go try resolve the currently logged in user. So to do this, we want to just send back whatever the user is that's in context. But first we need to add that user to context. So come back into the index, and here where we're logging out context, let's say if context dot request dot cookies dot access token, because we called our cookie access token, then let's try verify the access token and add the user to context. So I'm going to say const user equals verify JWT, and we created our verify JWT function before. And we can also pass in our user object as the generic. Then we want to add context.request.cookies.access token. So we're basically just creating this user from the payload that's inside the access token. We're not doing any actual database requests here. Then we want to say context.user is equal to user. So TypeScript is not going to like this. So a better way of doing this would be to say const context is equal to context, and then we can say context.user equals user, and then we're going to return context. And let's type this context here as our custom context. So say context, because verify JWT either returns our generic here, in this case user, or null, context.user needs to be user or null. So let's go into here and say user or null. So to return the value of context.user, come into the user resolver, and we're going to get context just like we do up here. So I'm going to copy this line here, and inside of me, I'm going to get context. Then I'm going to return context.user. Let's come back and we can hit this me query. And you can see here we get an actual user from the database. So let's go ahead and start working on our products. So I'm going to start with a product schema. So I'm going to say product schema.ts. And I'm going to add an object type. So export class product. We're going to have a field. Remember, field is the GraphQL field. It's going to be of type string. We're going to have ID of string. And the reason we don't have prop on here, like we do for the other properties, is because when we define a Mongoose model, we don't need to define the ID. The reason we're defining it here is because we want to define it in the GraphQL schema. Let's copy this line down, and our product is going to have a user. So to create a product, you have to be logged in, and we're going to add the user's ID that created the product to this user field. Let's say at prop, and we're going to add some arguments to this. So we're going to say required is true. And then we're going to say ref is equal to a function that returns user. And then for TypeScript, we're going to say ref, and ref comes from Typegoose, and it's a generic that takes a user. So our product is also going to have a name, and name is just going to be a string, and it's just going to be required is true. Our product is going to have a description. It's also going to have a price. And we're also going to have a product ID. So you could obviously just use the underscore ID if you like, but I'm just going to show you how to create a product ID with nano ID, because this is quite a handy little feature. So we don't want to have to input the ID. So we just want to set a default value. So I'm going to say default is equal to a function that returns a string. So inside of this string, we're going to prefix this with product underscore, and then we want to call nano ID, and then we're going to execute that. And then we also need our product IDs to be unique. So let's create this nano ID function here. So if I come up to the top and I can import custom alphabet from nano ID, and then I can create my custom alphabet. So I'm going to say const nano ID is equal to custom alphabet. So I just want to use ABC and 1 to 9. So I'm going to say ABC, D, E, F, G, H, I, J, K, L, M, N, P, U, V, W, X, Y, and Z, 1, 2, 3, 4, 5, 6, 7, 9. So this means that we won't get any really weird characters inside of our ID. And then the second argument is going to be a number, and we want our ID to be 10 characters long. So because we're going to be finding products by the product ID, let's add an index here. I'm going to say at index. And just like we did before, we're going to say product ID, and we're going to give this 1. So if you want to learn more about indexes, you can look those up in the MongoDB documentation. You can do all sorts of cool things with indexes. While we're in here, let's export the product model. So I'm going to say export product model is equal to get model for class. And then we're going to say product. And then in the generic here, we're going to say type of product. And this needs to be export const product model. So we're going to have 2 inputs in here. So we're going to have one for creating a product and one for getting a product. I'm going to say input type export class create product input. And we can copy a lot of this from our actual model. We want price, name, and description. So we just need to remove prop from here, because this is obviously not a Mongoose model. Price needs to be a number. And we can omit the return type on field. So let's add some validation to description and price. So I'm going to say at min length, and this is going to come from class validator. And you'll see the minimum length is going to be 50 characters. And then we can have a message if this is violated that says description must be at least 50 characters. Let's do the same for a max length. And the max length is going to be 1000 characters. The description must not be more than 1000 characters. And for price, let's say is number. And we're going to say it has a minimum value of 1. And that's so you can't have products that are less than $1. Okay, so let's say at input type, and now we're going to create the get product by product ID input. I'm going to say export class get product input. And we're just going to have the product ID here. I'm going to say product ID. Okay, so let's go create our product service. So inside of services, I'm going to create a new file called product.service.ts. Let's say class product service. Let's say export defaults product service. You obviously don't have to use classes here. You could just export a bunch of functions. And in fact, that's probably the way that I would rather do it. The classes keep it consistent with what TypeGraphQL requires. I'm going to say async create product, and then we're going to have some input here. And the input we've already typed up. This is going to be create product input. And we're also going to require a user that we didn't define on create product input. So I'm going to say and then I'm going to say user, then I'm going to say user comes from the user schema. And we're just going to require their ID. Now let's return product model dot create. And we're going to create this with input. So now let's create a function for finding product. Async find products. And this doesn't require any input. So I'm going to return product model dot find dot len. And if you wanted to do any pagination logic, this is where you would put your pagination logic. And you would also require some input here, like the page, the number of items to skip, and the number of items to get. I'm going to say async find single product. And for input, I'm going to have get product input. Then I'm going to return product model dot find one input, and then we're going to call dot len. So this is one nice looking service. Now let's go create some resolvers. I'm going to say product.resolver.ts. So we're going to use our @resolver annotation. And say export defaults class product resolver. Inside of our constructor, we're going to do the same thing that we did inside of our user constructor. So I'm going to copy this. I'm going to paste it. Instead of user service, we're going to use a product service. And then we're going to have a product service is a new product service. Then we're going to have a mutation that returns a product. And this mutation is going to be create product. And we're going to have arguments. So arg comes from TypeGraphQL. We're going to have input. And this input here, I'll just go over to our playground. And you can see in our object down here, we need to name our object input. And it means we can use this create product input as a named variable. Otherwise, inside of your mutation, you're going to have to list out all the input items. And that's quite annoying, I think, especially if you want to change the input items, then you don't need to actually change any of the usage of your mutations or queries. So we're going to name our input input, and then we're going to type it with create product input. Then we're going to use context Don't forget to execute this context decorator. Then we're going to name this context, and it's going to be of type context that we defined earlier. So I'm going to say const user is equal to context.user. Then I'm going to return this .product service .create product. I'm going to spread our input because we need to combine our input and a user ID into one object. Then I'm going to say user is equal to user.id. The problem here is that user inside of our create product input cannot be null, but user according to context can be null. So we can use the exclamation here to tell TypeScript that this user is never going to be null. But how can we guarantee that? We can guarantee that with an authorized annotation. So up here we can say authorized, but what does this actually do? Well, at the moment it does nothing. So we can create a utility and we can add that utility to our schema as auth checker, and that is going to do the authorization checking for us. Let's create a new file called authchecker.ts. And I'm going to say const auth checker. And then we're going to type this as auth checker, which comes from TypeGraphQL. We're going to pass in our context as the generic. We can say equal to the function, and we're going to return either true or false here. Let's export auth checker. So inside of this callback function here, we're going to get root, we're going to get args, and we're going to get context, and we're going to get some info. So the thing that we really care about is context. Specifically, we care about context.user, but we just want to return true or false. So let's add some exclamation marks here. And this is going to say if the user does exist, return true. Otherwise, just return false. So if this function here returns false, then authorized is going to be false. And so we're going to get an authorized error. So let's uncomment this here, and we can say auth checker to get VS Code to import it for us, which it didn't. So we're going to have to import auth checker from our utilities. So now let's go try create a product. The unknown type create product input. Did you mean create user input? No, I didn't. And the reason that it's asking us if we meant create user input is because in our resolvers, we haven't actually added our product resolver. So let's add product.resolver. We can call this product resolver. We need to add this to our array of resolvers. Now let's try this mutation again. And you can see we successfully created a product. Let's clear the cookies here. So we'll send this along with no cookies. And you can see we get access denied. You need to be authorized to perform this action. And that's because our auth checker function would have returned false. And so we're now not authorized. If we come to the product resolver, and I'll comment this out. So now it's not going to check if our user is authorized. Try create this. And we can see product validation failed. User is required. So we have user being required on the model. You can see here, user is required, but user is undefined, and undefined does not meet the required validation. So we need to have this authorized decorator here. So let's add some queries down here for getting a single product and getting multiple products. I'm going to say at query is going to return an array of products. So we wrap this in our array brackets, and this tells GraphQL that we're going to return multiple of these products. So I'm going to call this query products. Some people call their queries something like get products. I think that's quite redundant because the word query represents that you're going to be querying for this resource. So I'm going to say return this dot product service dot find products. Let's go test this out. We have our products query here and it returns an array of products. Let's copy this query down here and we're going to call this find product. And we need to remove our array brackets here because we're just going to return a single product. And we're going to have some arguments of input. And we're going to call this input and it's going to be type of get product input. And then the service we're going to be calling is dot find products. And we're going to pass in our input. Let's come back and we can get a product ID from our list of products that we returned. And then inside of our get product input, we can put our product ID. And then we can query for this product. And you can see here, can it return null for non-nullable item product.id. So the reason we're getting this error is because product is non-nullable, but we're returning null. So the issue is we're calling find products. This should be find single product. Let's try this again. And we get our product back. One other thing that I want to show you is for me, if the user is not logged in, you can see here we get an error. It says cannot return null for non-nullable field query.me. But this is not really what we want to do. We just want to return null. So let's come back to the user resolver. For the me query, we can add some options. So I can say nullable is true. Let's go back and make this query again. And you can see we get null back for me. And this is more what we want here. So that is how to create a GraphQL API with TypeGraphQL. If you enjoyed this video, please make sure you like and subscribe and turn the notification bell on so you get notified whenever I create a new video. Before we close out, make sure you've joined our Discord server and you can ask any questions about this video or any other video that I've created, and you can chat with the other developers inside of the Discord. See you in the next video.